Nice to meet you. My name is Shigehiro Nakamura. Today, I will explain 5M plus I.
From now on, I will explain the 5M plus I created by Mr. Nakamura. The main points of the explanation are the 3 points shown by Mr. Nakamura on the left side of this figure as follows. What is 5M plus I? How to use M plus I in a factory? And usage effect of it. I would like to explain the following 3 points. First, what is the relationship between manufacturing and 5M plus I? Second, between productivity improvement and 5M plus I. Third, relationship between production development history and 5M plus I. I would like to introduce the relationship between corporate activities and 5M plus I. One of the purposes of corporate activities is to improve profitability. Cost incurred status in a production process. Please look at the figure. The manufacturing industry needs a manufacturing base of land, buildings, and equipment to produce products. When we look at these subjects in monetary terms, these are fixed assets on our financial balance sheet. In addition, in order to improve profitability, these targets are required to have high technology. Product production is a left-to-right manufacturing process, as shown in the center of the figure. Product production requires 5M plus I work and their costs. The result of adding these costs is the total cost on the far right. Here, if the cost exceeds the sales, the corporate profit will be negative, so this company needs improvement because it needs to be improved in each process. The figure on the far right shows activities performed by a company. The important point in the manufacturing industry is customer-oriented manufacturing. In short, manufacturing that is welcomed by the market will increase sales. The upper part of the figure is the process of purchasing materials based on the profits obtained. This is part of the current asset cycle of Treasury. In this way, when we look at production activities from the perspective of business finance, we can catch that works of 5M plus I are very important for these activities. Just as Mr. Isaac Newton once noticed gravity when he saw an apple fall from a tree around 1965, it is difficult for people working in a company to notice individual effects of 5M plus I in production. For that reason, I would like to show the effect of 5M plus I in this figure. The frame of this figure is the manufacturing industry, and the center is the production process. If there are some losses here, the cost will be increased. So this plant needs many improvements to quality, cost, delivery time, safety, include SDGs and employee morale. Moral means efforts to improve manufacturing skills. These Q, C, D, S and E, M correspond to the foundations that strengthen the foundation of the factory. For this reason, I made a diagram with the image of a strong stake that supports the factory. For such measures we take in the manufacturing industry are the enhancement of 5M plus I described above the manufacturing process. Here, 5M is the level up elements of each production factor, but information means the level up of production control. 5M plus I is an object where it is difficult to see the power of waste elimination, like the attractive force on the earth. However, in the manufacturing industry, each level of 5M plus I should be clarified and improved. Even if we mention the existence of 5M plus I in a manufacturing factory, it is just only an explanation of the situation where there are eyes, hands, feet, etc. in the body. But this is not an explanation of activities to obtain some results by using those elements. For this reason, JMA Production Technology Study Group members and Mr. Nakamura organized the industrial history and organized the requirements that the invisible 5M plus I was developing world industries. At the top area of this figure shows the history of industrial development. As you can see, the industry was initially craftsmanship. After that, the industrialists analyzed the craftsmanship work steps, and then analyzed and standardized the method. A well-known example of the result of utilizing standardization was the conveyor, which was carried out by Ford first for the standard time advanced by F. W. Taylor. Looking at this process from a 5M plus I perspective, This history shows an evolution from a person to a method level. The evolution of technology was being progressed further with the times. In the process, industrialists weighed some of the work standardization and placed it in measuring instruments and jigs. In addition, industrialists were advancing many technologies and they assembled such measuring instruments and jigs into the equipment. This is the birth of automation equipment. As the era progressed and the IoT era approached, advanced industrialists were promoting many highest efficiencies in production control as well as the use of IT for these types of equipment. As mentioned to this presentation shows the process of effectively uses to 5M plus I. I would like to provide a case study so that you can experience measures to improve efficiency using 5 meters plus I at the manufacturing site. After that, I will show you how to analyze and use 5M plus I in the following steps. This case study is a case study of improvement experience explained by the late Mr. Shigeo Shingo, who was famous for the book Shingo Shingo, at a lecture by JMA. I would like to explain main points with the next figures. For everyone to use the viewpoint of this case study is to make good improvement to poor peeling of oranges and to get more efficiency method by using 5M plus I looking point. Now, I will start explaining the case study. When Professor Mr. Shingo visited a canning factory in the Kyushu area of Japan, the factory manager consulted with him that he was in trouble due to lack of work skills, so the two of us immediately went to see the production. At these peak times, factory employees alone are not enough. The manufacturing site was the heyday of mandarin oranges, and many temporary hired part-timers and employees of this company were working enthusiastic about peeling Japanese oranges. Each worker proceeded with the work according to the procedure shown in the figure. In step 1, many oranges are put into the conveyor from a box. In step 2, each worker picks up oranges from the conveyor. In step 3, the worker holds the knife, makes a cut in the orange peel as shown in the figure, returns the knife to each decided storage place, then peels the orange by hand. In step 4, the worker puts the peeled orange in the box as shown in the figure. However, when each worker used the knife in step 3, the tip of the knife sometimes entered the body of the orange, causing a defect of tearing the thin skin covering the orange. The problem that the factory manager explained to the teacher was that the percentage of defects exceeded 10%. Scratched oranges will not be canned because the juice of oranges will come out, so they will be discarded. For this reason, the factory manager explained to the teacher, I train a lot of part-timers and then put them into this work, but not enough and there are differences in skill in these works. Therefore, I am in trouble because the defects do not decrease. Mr. Shingo came up with an idea that he had been thinking about for a while, and he presented it to the factory manager. Then, when he tried the teacher's idea, the productivity was immediately increased by 1.3 times and the defect was reduced by 1/50. The question is from here. What kind of method do you think Professor Mr. Shingo's idea was? What do you think? Please present your idea from now. Please make your good idea and solution. From now on, I will show you some idea samples. How do you think each idea? First, what about knives with a stopper? Second, after registering the worker's skill, why not choose a person with high skill? Third, what about education using video? Fourth, how about knife work for highly skilled people? After that, peeling work for part-timers? Fifth, how about turning it into a peeling robot? Sixth, how about developing a skinless Japanese orange with biotechnology? And others. Professor Mr. Shingo's solution was, how about knife work for highly skilled people? After that, peeling work for part-timers. In fact, it was a great solution to instantly increase productivity by 1.3 times and reduce defects by 1/50. The reason was that the veteran made a cut in the orange with a knife, which reduced errors, and the part-timer performed the peeling work only, so the knife by part-timer was no longer handle. The JMA Production Engineering Subcommittee submitted many ideas that can be seen in this figure by brainstorming. And you can think that this company should be able to choose any idea as long as it is an effective idea for mandarin orange peeling measures. For this reason, this company will need to use 5M plus I analysis to evaluate these ideas from now. Mr. Shingo's idea was one of a wonderful measure to raise the productivity of the mandarin orange factory in a short time. However, there were many other ideas. So what was each idea based on 5M plus I? I would like to show in this table the contents of Mr. Nakamura's arrangement of the factors of the idea at the JMA Production Engineering Subcommittee. Analyzing with 5M plus I, it can be seen that Mr. Shingo's idea is number 1 in this table, and that the cause of the problem element is men and women with 5 meters plus I. The measure to divide the part-timer based on the number 2 skill and decide the employment is 5M plus I information. For other ideas, as Mr. Nakamura has shown on this table, each problem occurring factor is as shown at the right end of the table. When evaluated with 5M plus I in this way, there seems to be a better idea other than the one presented by Professor Mr. Shingo. So we would like to move on to the procedure of evaluating all ideas with 5M plus I. As explained earlier, I of 5M plus I is the overall management and control of 5M. Therefore, after registering the worker's skill, why not choose a person with high skill? Is excluded from this figure named 5M step improvement method. Then, I will explain the structure of the 5M step improvement method. The vertical axis on the left side of the figure is each development factor of the manufacturing industry, which was introduced earlier along with the history of industrial development. The bottom is men and women level, and the top is machine level. Since this kind of technological improvement has evolved step by step in the history of industrial history, Mr. Nakamura named it the 5M step improvement method. The horizontal axis of the graph on the right side of the figure is the man-hours for training workers, the degree of defect occurrence, and the amount of investment. The solid line curve on the graph depicts the situation where work and training loss is reduced by the change and improvement of 5M. The dashed curve is an image of the need for an investment amount required for improvement. When you will use this 5M step method, in the case of this example, you will be able to find that this orange peeling jig with a stopper is effective from Dr. Shingo's proposal. I would like to explain the improvement of the measurement stage using the stopper usage example at the bottom left of the figure. The skin thickness of Japanese orange is almost constant. Therefore, if we measure this dimension and use a stopper jig that stops when the cutter enters the thickness of the skin, the work of making a cut in the orange skin before peeling the orange will be able to be 0 defects. And it will be possible to do it quickly. With this measure, not only the difference in work skills will disappear, but also, this measure will be more effective than the idea presented by Professor Mr. Shingo earlier. If you search on YouTube, you will find that there are many ways to peel oranges. Please try it. After that, I think that the previous factory probably advanced to the stage of using the stopper jig as shown in the figure. The reason is that Professor Mr. Shingo told Mr. Nakamura and others that improvement is eternal, when you will read Shingo Shining's book. Reason is that Professor Mr. Shingo once told to Mr. Nakamura and others there is no progress just by reading and imitating this book. Students should think about more effective measures by themselves with the book as a hint. This teaching accurately shows how to read and use this kind of book, I think. This company will have such a peak of work every year. When that happens, expect biotechnology measures should be taken as a distant future measure. Anyway, this company will have to progress some further improvement, for example, to the level of automation shown on the right side of the figure. With such a process and case study, Mr. Nakamura and his colleagues created a 5M stage improvement method. There is POCOC in the measurement stage of the 5M stage improvement method. Please look at the figure. The first is the USB configuration of the PC. On the contrary, it is a device that cannot be attached. The second is the battery wiring. We are using the measure method to prevent the phenomenon of mistaken plus and minus. The third and fourth are also methods that definitely work using the measure method. In this way, Pocock is an example of a technology that uses measurement to achieve zero human error. This figure shows 3 examples of Pocock that make good use of dimensional differences. A is an example of preventing mistakes in mounting parts by adjusting the height of the parts. B is a check of the circuit that the part is not attached. C is a method that uses the gap between the 2 rolls to get only parts with the desired dimensions. I would like to introduce an example of an optical sensor that is commonly used. Pocock using sensors is an intermediate tool between measurement and equipment used as one of the tools for device. This is the optical sensor mounted on the conveyor. The sensor checks to see if the specified case is loaded onto the conveyor. This is a sensor attached to the parts feeder. It is a method to notify by an alarm that there are no parts. In this way, the sensor is a human error countermeasure tool that is often used at the measurement stage. I would like to illustrate the use of gauges in a car factory. Because, when inspecting an engine, 10,000 to 30,000 places must be inspected. If this is measured one by one, it will take an enormous amount of time. At that time, use such a figure gauge. This is an example of a measure that regards the target as the measurement stage. Japan industry created the fishbone analysis that utilizes sometimes but not every time 5M. This is a world-famous method by Professor Ishikawa. As shown in the figure, this method is a brainstorming method based on 5M, which lists many factors. Fishbone analysis I is not used in 5M plus I analysis. When we solve a problem, we will pick up a few ideas and we immediately give a concrete technique and evaluate the level and application of the idea with the 5M step improvement method. The 5M plus I analysis and the 5M step improvement method are not brainstorming methods, but methods that evaluate the existing technology and extract the best plan at the site or in kind. Therefore, it is a method that is significantly different from the fishbone analysis method, which is performed by a group of experts in the room. Original fishbone analysis was a method developed with reference to the case where Dr. Noro used it for the countermeasures of the blast furnace shown in the figure and achieved good results by it. In Japan, at the beginning of 1900, we used the technology introduced from Germany, but it was not possible to produce iron in the blast furnace. Everybody cannot see the inside of the blast furnace. Therefore, Dr. Noro gathered veterans from the field and asked them to list all the problems that occurred in the blast furnace. To sort out this problem, Dr. Noro used an information classification method similar to original fishbone analysis, and as a result, the cause of the problem was clarified, and the problem was solved in the process shown in the figure. In this way, the initial method was to organize factual information, not the fishbone analysis method used as a brainstorming tool. As you can see, there are 2 methods for fishbone analysis in the world. In addition, there are still many other ways to improve. 5M plus I analysis and 5M step improvement method are also one of examples of improvement tools. When you hit a nail, it is more effective to use a hammer than to hold the screwdriver in the opposite direction and hit the nail. In this way, please select the improvement tool according to the purpose of use. From now on, I would like to introduce a method that Mr. Nakamura was achieving in many companies, which was using the 5M step improvement method with the participation of all employees to make the factory first class. Explanations are as shown in the figure. The previous countermeasure for peeling oranges was a method of dealing with one problem in the factory with 5M plus I. For factory development, it is necessary to improve and strengthen individual elements. Furthermore, in addition to this measure, this figure is a method that uses 5 meters plus I as a measure to make the entire factory excellent in a short time. Mr. Nakamura himself used this procedure when launching AAP in the United States. He was one of the managers of AAP, but as a result of using the procedure shown in this figure when starting up the factory with 200 local people who had no experience in aluminum production, it was initially assumed to be in the red for 5 years. However, he used this procedure at automobile parts aluminum wheel production plant, then it turned profitable in 1.5 years. The details of this procedure are step by step from bottom to top, as shown in the figure. Since each method and level has its limits, we will change the improvement tools. First, match the activity directions of all employees. When you reach a certain level, move on to second, streamlining work procedures. Third, for those that can be measured in the work, take technical measures in terms of method. Fourth, measure the target that can be equipped by collecting methods. Fifth, when the factory improvement reaches the limit, we will gradually move to the improvement of the material equal product design stage and the new customer-oriented new product measures. The following companies are particularly effective in this procedure in a short period of time. A. Establish a new manufacturing industry. B. Suffering and confusion due to deficit. C. Furthermore, companies that need to be rebuilt in a short time. I plot the application of 5M plus I from another point of view, so please have a look. 5M plus I is applicable to the 3 points shown in the figure. The above 5M stage improvement method targets the manufacturing at the top of the figure. This is called hardware countermeasures. In order to raise the level of such a manufacturing process, it is necessary to take measures for production control in terms of that is, information. That is called software countermeasures. And since these two factors depend on the efforts of the employees working in this company, hardware measures are necessary for the development measures of the factory. There is a famous phrase in the industry that if a ship does not have a map, it will be only wandering. The figure shows the image between a future development of a factory and map. For this reason, if each factory does not have a tool to hit a map or compass and proceeds with activities for the future, it will suffer a lot of waste of time due to many obstacles. But, here, companies should pay attention to the contents of the map. Each company's map depends on the future purpose of the company and is unique to the company. About 30 years ago, many companies introduced lean manufacturing without thinking about this major checkpoint. For this reason, the successful case was reported to be 5%. In this meaning, even the world-famous factory improvement method will not be effective unless it matches the improvement of the company. This natural law can be compared to an activity similar to the form using a tourist map, even though a company needs a renewable energy development map when it supports SDGs in the future. The future map of each factory is unique, but there is no company difference in its composition from now. I would like to introduce the structure of the production technology map that Mr. Nakamura has used to support each company. Please see the figure. The medium-term plan for the factory is shown at the left end of the figure. For this purpose, various investigations and examinations are required at each factory. After the implementation of this medium-term plan, the company will state the numerical targets such as quality, cost, and delivery dates shown in the frame A of him. At the same time, the company will compare it with other companies in the same industry and leading companies. After this arrangement, the company sets the state goals shown in frame B. For example, the level of manufacturing technology, the level of JIT application, and the level of automation and skills required by the company. This evaluation and comparison will be made in comparison with the leading companies targeted by this company. Also, at this time, examples that are applicable to different industries will be incorporated in the form of benchmarks. As each technology in the item of frame B improves, the numerical target of frame A will rise, but it is the employees who take measures against it. Therefore, after writing the department in charge on the horizontal axis with the items in frame B on the vertical axis, write the name of the person in charge and the action items in this matrix. This is the sky blue frame to the right of the frame B in the figure. With this procedure, the examination of the feasibility of achieving the medium-term plan has been completed. After that, Follow the realization status of the medium-term plan with the image on the right side of the figure. I would like to explain the 5M step improvement method for the production technology map with this figure. If you would like to obtain a production technology map, please contact the NK Institute. The figure is a production technology map created by Mr. Nakamura. When he consulted with each company, he showed this figure and used it as a base for creating a map unique to each company based on the production technology map created for that company. Please see the upper left of the figure. This is a description of the 5M step improvement method. Each factory sets the level of numerical targets and state targets based on this concept. The levels are in the order of person, method, measurement, equipment, thing equals design shown above. So far, I explained the use of the 5M step improvement method for the production technology map. With this explanation, I think you will understand how 5M plus I can be used to improve and innovate the entire enterprise. You can use 5M plus I not only the previous measures for peeling oranges but also in many ways for on-site improvement. Now, I would like to introduce some of the examples that Mr. Nakamura carried out. In addition, this method is an example of measures to help improve the level of the map state target explained earlier. Currently 5SS is a world-famous method. However, there are two types of 5SS. One is beautification 5S for the purpose of beautification, and as a result of improvement, there are no problems and beautification can be obtained. And others is Mr. Nakamura has been promoting 5SS. This is the latter improvement of 5SS, which is directly linked to management. The definitions are as shown in this table. Please look at scientific improvement methods listed on the right side of the table. When you will use 5SS that is directly connected to management 5SS, everyone in the factory should know the effect first and use it. At that time, the evaluation of 5M plus I as shown in the figure is useful. Please look at the matrix in this figure. The vertical axis is the improvement factor 5M plus I in the factory. The management effect, Q, C, D, S, M are displayed on the horizontal axis, but if you position each 5SS in this matrix, you can see the improvement target and method. The target of sky blue is 5SS, which is expected to be effective. For example, TPM, which you all know, is a measure to reduce failures, and equipment cleaning and inspection can reduce costs. Beautification 5S and Office 5S shown in this matrix are shown in yellow because they have little management effect. When you will want to use motion economy 5S, use photography. This figure is the method shown to the trainees by the late Professor Mr. Tomoho Sugiyama of JMA. Both of these are examples of teaching trainees how to improve the shelves. Please see the following figure for improvements in other areas. Improvements to other areas are shown in this figure. To the important point about this kind of improvement, I do not recommend a method of improvement based on what others have pointed out the problem. This is because after learning waste and improvement methods using the IE method, it is beneficial for the people involved in the workplace to take videos of their work conditions and improve them. Next, I will introduce an example of video improvement. I will show you a drilling work of aviation parts. In video analysis, waste can be clearly understood by using the process analysis shown in the figure. Please look at the table. This is because all items other than those indicated by circles are targets that can be improved as muta. Muta means loss. From now on, I will start the video. When the workers of this company see this work, is it possible to use a tabletop drilling machine by fixing the parts with a jig? You should think. This is the point of improvement. Here, I will omit the details of improving this work. Please see the figure. In this example, the man-hours were reduced by 42% and safety was ensured by using a jig for fixing parts and a tabletop drilling machine, resulting in 0 defects. The important point in using 5M plus I is that the people working at the improvement site know the significance of the improvement and try to improve it. This is a diagram showing the significance that eliminating waste not only raises the level of one's work, but also increases corporate profits and personal income and leads to happiness. At the company that Mr. Nakamura was supporting, when operating 5M plus I, it was a voluntary improvement made by the person in charge of work at the manufacturing site. Most of the voluntary improvements are done in small groups on site. As shown in the figure, manufacturing and improvement are the jobs at the manufacturing site. Therefore, each company conducts on-site training to eliminate waste, but as shown in the figure below that one day one small kaizen is learned, even without a large investment, this manufacturing site doubles the production in 3 years. Mr. Nakamura is implementing this method in many companies and it was effective, but already the same method is the famous Kota Kaizen method that Toyota and Canon also used. Toyota is one of the world-renowned companies because many companies is setting an example in terms of improvement technology in many respects. When Mr. Nakamura interviewed Toyota, Toyota said we have a map also, it was very similar to the content introduced this time. But they never open it to him, because of confidential. This is quite natural, I think. Therefore, Mr. Nakamura analyzed the progress that Toyota has been working on. Also, what was done on the 5M plus I side in the process. Organized. From now on, I would like to introduce the contents of results. First of all, I would like to introduce the reason why Toyota worked on Toyota Production System and JIT. As you can see in the figure, around 1950, Toyota investigated all the companies in the world to find a way out of the deficit. As a result, we set up a strategy to completely eliminate waste as shown in the figure and started the challenge. The process by which Toyota developed JIT was a series of try and error. As a result, we have systematized the diagrams that everyone is familiar with. Also, there was a lot of support from Professor Mr. Shingo here, but in particular, the development of a single setup, name is SMED, and Pokawak is famous, and this content is as you can see in the book of Singo. Also, if you analyze the details, you can see that the analysis of 5M plus I was used skillfully. The activity to develop JIT at Toyota was extremely difficult. And, in try and error, the JIT method was developed with the progress shown in this table by the efforts of the people involved in the field. Looking at this effort, we can see the difficulty of independently developing the world's first method. As an example of Toyota's try and error, Toyota made a big mistake when Toyota built a fully automated factory at the Chahara factory in the 1980s. However, I will show you an example in which Toyota succeeded in manually incorporating what it learned from the automation into the JIT production line at the Kamigo factory during cars Bain RAV4 production. This is a tire screw fix process. In this process, the functional unit of the automatic machine was used, and the combination of centering by humans and screw tightening by automation ensured higher productivity than automation. The background of Toyota's strategy of developing JIT with TPS, which I introduced earlier, was the utilization of the target cost perspective in this figure. Also, in the case of video introduced earlier, it may not be a good idea to immediately tackle the 5M plus I machine's level of automation when improving. Rather, it should be interpreted as an example showing that it was effective to consider the measurements level from methods and incorporate automation of screw tightening into human work from the viewpoint of the 5M step improvement method. Can be done. IE method is one of the tools for improving your manufacturing site. Moreover, there is a teaching in the improvement guidance that improvement should be learned by precedent. Mr. Nakamura saw this case of Toyota and learned the following points when faced with challenges. First, the countermeasure method is not limited to the machine stage. Second, do not give up until problem solving. Third, try an error method. Try to lead to success even if you combine methods. In this way, it is very important that we will use 5M plus I as a tool for management improvement.